step at a time. So the first thing I'm going to do is draw the scaffolding of serine. So there's the alpha carbon, the alpha amino group, and the alpha carboxylate. And by default, I tend to draw it in the protonation state that it is at pH 7 because that's often relevant, which is this. But we're not going to worry about that right now. Okay. And then I look up the side chain and I draw the side chain. So let's say we're going to draw it at pH 8. And there are two relevant pKa's. This one is a pKa of 9. This one has a pKa of 2. And I'll say that for all of the amino acids. They're a little different, but I think it's perfectly fine to assume that all of them are 2 and 9. So at pH 8, what we have to do is look at our pH relative to the pKa. If the pH of the solution is below the pKa, you're going to have the protonated state. If the pH is above the pKa, there are fewer protons around and things will be deprotonated. So if we check what we have here, at a pH of 8, the pH is below the pKa of 9, and so we're going to expect to see the protonated form. And remember, the two forms we are comparing for the alpha amino group are these two. And so this will be at pH 8, and that's what we have. At pH 8, and we look over here, 8 is way higher than the pKa of 2, and so there's going to be, with a low pKa, this carboxylate really is going to want to give up its proton at most pHs. And since 8 is greater than the pKa of 2, that means there's fewer H pluses around in solution, and there's not enough to stick to that guy, so it's going to be in the carboxylate form. So this is the form of serine that you would have at pH 8. Well, what if we went to pH 1? pH 1 is very low pH, which means very high concentrations of H plus in solution. So things are going to tend to be in their protonated states. And at pH 1, it's lower than the pKa of 2, and it's lower than the pKa of 9. And so both of them are going to be in their protonated states, which would look like this. So that's what serine would look like at pH 1. At pH 10, this is very basic. There's very few H pluses in solution, and so things are going to tend to be in their unprotonated forms. And so with a pKa of 2, definitely the carboxylate form is going to be the dominant one, but also that alpha amino group is going to lose that extra proton, and this would be the form of serine at pH 10.